Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. We stopped here. In these examples, I was trying to show you how to write the cell notation, right? So it means this is an example. Of course, you are going to see also the solution. It's there in your book, يعني, in your slides. يعني. It's not new, يعني, or يعني, you will see that. Anyway, we have written the two reduction half reactions, right, the left, and of course, if I want to give the overall reaction, I will do what, right, minus left. That gives me the overall reaction. Now the question was asking me to write the cell notation. How do we write the cell notation? Now let's say what do we have on the left? What do we have on the right? Okay, on the left we have here, this is example number 2, right? Okay, so on the left I have Zn2 plus and Zn, okay, and on the right I have Fe3 plus and Fe2 plus. Okay, now what is happening here? You could see on the left I have what? Oxidation. This is oxidation, but we are what? Flipping, as you are aware, right? Okay. So we have what? Zn solid. It is what? It is the solid material, and this is Zn2 plus. This is the aqueous, right? Okay. And of course, I will have then what? The salt bridge, right? Okay. The salt bridge. Okay. So what will be the next? The other one. This is the left. The right. The right. I have what? Reduction. So I have what? Fe3 plus, okay, aqueous, right? Okay, and in the same solution, it will be Fe2 plus. So in the same solution, Fe3 plus will be converted into Fe2 plus. They are both aqueous, right? Okay. Now, so I need to add electrode, okay, material. If electrode material, of course, it will be platinum solid because it is inert. It's not going to be interfering with the reaction already happening at that electrode. So we usually, if we don't have a solid and we need to have a solid, we prefer to use something inert that does not interfere, right? Okay, so that's why I will have what I have. This is the notation. So Zn2 plus aqueous and Zn solid on the left, and on the right we have Fe3 plus and Fe2 plus. They are in the same aqueous solution, right? Okay, and this is what we have. Okay, now let's talk about the example number 3. Example number 3. Okay, in example number 3, of course, it is also a new idea. What is the new idea here? Okay, the new idea here, it is that I need actually to, okay, see here the example number 3. Okay, so what is the new idea? Sometimes it is easy for us, sometimes it is easy to see which species undergone reduction and which is undergoing oxidation, but sometimes it is not easy. Now, usually, as we said, we have to start by writing the reduction half reaction. But if it was difficult for me to see which species has undergone reduction, because I always have to start by writing the reduction half reaction. So I will see the oxidation. So I am looking at CCSN. Okay, so SN2 plus and SN4 plus, right? Okay, it is obviously it is what? It is oxidation, right? Okay, so this is obviously that it is undergoing oxidation. So if it is undergoing oxidation, it means it is on the left, right? Okay, so it means it is what? SN4 plus. Of course, we are writing it as what? As reduction. So SN4 plus is giving me SN2 plus, right? Okay, that is the reduction half reaction, which was actually truly it is oxidation, but we are flipping anyway. This is the oxidation. Now what about the reduction? If everything else that we have here, okay, the remaining that we have in the reaction should be representing the reduction. Okay, now, so it means I have to go to the table and find the reduction half reaction which involves these species. So if I go to the potential here, so I will clear everything that I have, right? Okay, so I will have, okay, so you could see now I'm looking at what? Here, see here, I'm looking here, somewhere here. See here, I want to see if I have, okay, the reaction I'm looking at. Okay, let's see here. I will put it here. So what is it we have? See here, this is what we have. Okay, so which one is going to be representing the reduction half reaction that we have on the right? Is it, for example, number 1 or number 2 or number 3? Which one is it? It's going to be, okay? It's number 1, right? It's number 1, right? Okay, because this is what we have. Yani we have MnO4 minus, we have H plus, we have Mn2 plus, and we have H2O. So it is, yes. So that should be here. I will write MnO4 minus, okay, plus 8 H plus 5 electrons. It is giving me, of course, okay, Mn, okay, 2 plus 4 H2O, right? Okay. Now there is one something that's very, very important actually. Okay, what is it? If we have to, when we write reduction half reactions, we always have to make sure that there is a match between the electrons on the left, on the right. In case the electrons are not matching, our overall reaction will not be correct. And of course, eventually the quotient will not be correct. Okay, and everything that we do based on that is not going to be correct. So we are going to multiply by what? So you could see this is 5 here, and this is what? This is 2. So I will have to multiply number 1 by 2. Okay, so reaction number 1, I will have to multiply it by 2, and reaction number 2, I have to multiply it by 5, so as to get what? So as to get a match between the number of electrons. So if I multiply by 2, this is going to be, okay, I will go down. Okay, so this is going to, I will copy. Okay, so that is going, now our reactions here are going to be like that. Okay, so that should be here. So I will have here, this is 2 here. Of course, this is going to be now what? It's going to be 16, right? Okay, that is going to be 16. Then I will have to have here what? This will be what? 10 now. Okay, and here it is going to be what? 2 here. And then I will have here what? I will have 8, right? Okay, that is if I multiply by 2. Now the other reaction, left, I'll multiply by 5. It means this is 5, and this is going, of course, to be equal to 10 again, right? Okay, which we must have. Okay, and this is going to be equal to 2, right? Okay, so this is our sorry, it is 5, 2. It is 5. Okay, so this is our reduction half reactions. But you are aware, if we multiply a reduction half reaction by a factor, it's not going to be changing the cell potential, standard potential or cell potential. It's not going to change, right? Okay, it's not going to change. Anyway, so how do we write the cell notation? Cell notation. What would it be? Okay, cell notation. Of course, this is going to be, this is what? Aqueous here. Okay, this is also aqueous. Okay, this is aqueous. This is aqueous. This is aqueous. And this is what? Liquid, right? Okay, so this is what we have. Okay, now let's write the cell notation. On the left, I have what? I have SN4 plus, okay, and I have also SN2 plus. So I will write it as what? SN2 plus, okay. Of course, it is here aqueous, right? Okay, aqueous. And in the same solution, it is converted to SN4 plus. This is aqueous. You could see that on the left, I don't have a solid. There is no solid on the left. So I will have to have what? I must add a solid here. Of course, it will be now, I will add what? Platinum solid. So I added platinum solid on the left because I don't have a solid. Okay. I will, of course, have a salt bridge, right? Okay. And then I will have to write what's remaining now. What's remaining now? I have what? MnO4 minus aqueous, and I have comma H plus aqueous, and H plus also Mn2 plus aqueous. Okay, now do I have to have the H2O in it? H2O, it is like a solvent. Okay, we can add it, we can leave it, it doesn't matter. Yani. You can add it or leave it, it doesn't matter. Yani. It is like a solvent, so we can add it or just leave it. Yani. So now I will have to add also, I must have what? Platinum solid. So I will add also platinum. Okay, so you can see that now I added the platinum on the left and platinum on the right because simply in my solution is, or my reactions, the two reduction half reactions, they do not involve any solids. Okay, so I will have to put platinum, the electrode, yani the plate and the wire is made of platinum. Inside the cell, in the solution, on the left I have SN4 plus and SN2 plus according to the reaction. On the other side I have MN4 minus, H plus, MN2 plus, whatever. That's going to, this is what we are going to have. Okay, now this is the end of course, you can see the answer here also. This is of course the end of this chapter. Okay, and we are going to start solving questions. Okay, so I will start by, okay, a question here, okay, which is this one here. Okay, this is going to be, let me see here. Okay, this is, okay, 9:15. Okay, you might say, okay, why didn't you start solving questions, previous numbers? Like what? See here, I have 9:15, whatever, and then I have what is the reason that I did not do that? Because I had not covered the whole material of the chapter. So there are questions that you cannot solve. Okay, so that's why I skipped those questions, because we simply cannot solve these. We have not covered the whole material of the chapter. Okay, now what do we have to do here? It says what? You have what? Hydrogen electrode. Okay, good. Do we know what a hydrogen electrode is? You have to know, because if you don't know, you won't be able to solve this question, by the way. So what is the hydrogen electrode? Hydrogen electrode, just to remind you, we explained it, right? Okay, this is the hydrogen electrode, right? Okay, now, but it is not a standard. Our hydrogen electrode now that we are talking about is not standard. This one is what? It is a standard. Standard, why? Because the pressure of the hydrogen is equal to what? You could see that this is equal to what? 1 bar, and the activity of the aqueous solution is equal to 1. Here, it is not, okay? So it means now, what I am going to talk about, it is not going to be 1 bar here, okay? It is not 1 bar, and this is not going to be activity equal to 1. Okay, so what is it? What do we have? We said now we have a hydrogen electrode in HBr. What does it mean? It means this solution is what? HBr. This is HBr solution. It means inside, what is providing the H plus? What is it providing here? Yeah, when we talk about, sorry, this is the HBr. Okay, so we have, right? Okay, now what we need now is to specify that the temperature is 25 degrees C. The pressure of the gas, it is 1.45 bar. Okay, fine. Okay, now the question is saying, well, now this is your, okay, I need, sorry. So this is my, okay, this is my hydrogen electrode. Now I have placed the hydrogen electrode, this electrode, I have placed it, this hydrogen electrode, I have placed it in a solution of HBr. The concentration here, okay, is equal to 5 millimole per decimeter cube, okay. And then I have repeated, okay, I have placed it, okay, exactly the same electrode, I have placed it in a solution of 15 millimole per decimeter cubed. So now I have two things, I have the electrode, the same electrode. One time it is dipped in a solution, one time it is dipped in a solution of 5 millimole per decimeter cubed, and the other time it is dipped in a solution of what? 5 and 15, right? Okay, 5 and 15. Okay, so what do we have to do? We have to the question is asking me to do what? Estimate what? The change in the electrode potential. Okay, I want to just change in the electrode potential. So it means that now I have to get E1, and I have to get what? E2, and then I have to get what? Delta E, which is equal to E2 minus E1. Okay, this is what I want to do. I want to get E1, I want to get E2, and I want to get delta E. Okay, now noticing that I am saying electrode potential, not a standard, the electrode. There is only one equation, the equation here that is what the Nernst equation, E is equal to E standard, okay, minus what? RT over naught mu F times ln Q. This is the equation that relates the Q quotient to the potential. Okay, now why am I talking about the quotient? Because when I change the concentration, the quotient will change. Now, what is not going to change? Let's see here. I'm talking about what? The pressure here, we said the pressure is not changing, right? Okay, right? The same pressure in two cases. Okay, now the temperature is the same. Now, what about the reduction half reaction? This is hydrogen electrode. Okay, reduction half reaction. What is it? Reduction half reaction. It means it is H plus to convert it to H2. يعني reduction half reaction. So we will go and look at it, and it is going to be here. See here. This is what our reduction half reaction, right? Okay. That is what 2H plus 2 electrons giving H2. That is equal, E cell standard is equal to 0 by definition. This is what how we define the standard hydrogen electrode. So I will say now that it is what it is going to be what? It is going to be 2H plus, okay, plus what? 2 electrons giving what? H2, right? Okay. That is of course a gas, and this is of course aqueous, right? Okay. Now, by definition, as we said, by definition, E standard here is equal to 0, right? Okay. It means E standard is going to be equal to 0 here, okay, and also here. E standard is going to be equal to 0 in both cases, because it is what? It is يعني the same hydrogen electrode, right? Okay, so the standard potential for the hydrogen electrode is equal to this, right? Okay. Now let's see. طبعا you have to know the R is going to be 8.314, okay, joule per mole Kelvin. The T, it is equal to 25 plus 273.15, which is 298, okay, 0.15 Kelvin. Okay, the F is going to be there in the conversion factor table or in the provided information, which is equal to 96485, okay, coulomb per mole. Now, if we look at the reduction half reaction, okay, you can see this is the reduction half. Sorry, this is the reduction half reaction, and of course, okay, you will be able to. Okay, I'll just do something here. Okay. Okay, so this is my reduction half reaction. I'll put it there at the top, right? Okay, so this is going to be here. Okay, so I'll be able to give the value of nu. Nu is equal to what? 2, right? Okay, so now we have all these information. What is it I want to do? I want to calculate E1 and E2, and then I want to calculate the difference. Okay, what do I have to do so as to calculate E1 and E2? Okay, I will say, طبعا I need the quotient. What makes the difference? It is the quotient. R is the same, T is the same, nu is the same, F the same, E standard is the same. It's only the quotient. So what is the quotient equal to? Quotient according to our reaction. Okay, so quotient, it is equal to what? According to our reaction, it is equal to what? Activity of, you could see that this is activity of what? Activity of H2 gas, okay, divided by activity of H plus aqueous, but it is squared. Right, okay, so this is our quotient, right? Okay, so our quotient is equal to the activity of H2 gas divided by activity of H plus aqueous squared. Okay, now activity of H2 gas, it is equal to the partial pressure of H2 gas divided by what? The standard pressure, okay, which we said it is equal to 1 bar. The pressure of H2 gas bar, and the standard pressure is 1 bar. Okay, this is the, okay, let me just do this here. This is going to be the equal to the activity of, okay, so activity now of what? H plus aqueous is going to be equal to the concentration, okay, of H plus, okay, divided by the standard concentration, which we said it is equal to, so P standard is equal to 1 bar, okay, and C standard is equal to what? 1 mole per decimeter cube. Okay, now you should not worry about that now. Okay, anyway, so what do we have to do? Let's go and do something here. Of course, I need to talk about, sorry, I need to use these again. Okay, so I will go here. So I will, okay, have them here. Okay, so now what is it I will do? I need to calculate the quotient. Okay, so the quotient is equal to what? Is equal to, I will put the quotient in terms of the concentration. So it should be what? It should be equal to this here, okay? That is, okay, divided by this here, okay? But it is supposed to be, now what? This is supposed to be squared, right? This is what? This is squared, right? Okay, this is squared, right? Okay, then I will say, because 1 1, okay. Anyway, if let's just leave it like that, yani. Okay, now I need quotient 1 and quotient 2, because I have reaction 1 and I have reaction 2. Reaction 1, it's not reaction 1, I mean concentration 1 and concentration 2. So concentration 1, it is equal to what? So I will say this is going to be generally quotient 1 is going to be, okay, quotient 1 is going to be what? The pressure now here, okay, of the H2, okay, gas is 1.545 bar. Okay, the concentration here, okay, it is equal to what? It is equal to 5. Okay, 5, right? Okay, this is for quotient number, okay, for quotient 1, right? Okay, so for quotient 1, this is what I have. I have the pressure equal to this, and this is the concentration. Fine. Okay, so this is what I have. Okay, don't worry about that. I will just, okay. So this is what we are going now to use. Okay, and now I need what? Quotient 2. What is quotient 2 equal to? Quotient 2, it is the same as quotient 1, but it is, instead of 5, we have what? We have 15. So it means this is what I have. What I will do it here, I will say now quotient 2 is equal to what? It is equal to, this is 2, right? Okay, it is equal to the pressure, which is 1.45 bar, divided by what? The concentration. Now the concentration is equal to what? 15, not 5, 15. So quotient 1, quotient 2. Fine? Okay. Now what do we do? I will go and look at what? At my equation, which is what? The delta E. Delta E. Delta E, I said it's equal to what? E1, E2 minus E1. Okay. E2 is equal to what? E2, we said it is E standard minus RT over nu F ln Q2. Okay, E1, it will be equal to E standard minus RT over nu F ln Q1. Okay, now E2 minus E1 delta E will be equal to, as we said now, it is equal to what? E2, okay, E2, right? Okay, that is E2 minus E1. This is E1, right? Okay, I'll put it, and then I'll substitute the signs. Okay, this is what I have. Now I will be putting the signs. Okay, what are the signs? This is E2 minus E1. Fine? Okay, so what will happen now? You could see that I can cancel the E standard. Okay, right? Okay, because I have minus here, it will be what? Plus. So it means this term is going to be what? Positive, right? Okay, it's going to be what? Positive. That is what I have here, and this is would remain as is. Yani it will not. The signs will remain as negative. So this is going to be equal to what? It is going to be equal to delta E. It is going to be equal to delta E. Now, what is it I can do? I can take common factor, so RT over what? Nu F, it will be what? Ln Q1 minus ln Q2, which means it is equal to what? RT over what? Nu F, okay, ln Q1 divided by Q2. This is what I'm going to have, which is what? Equal to delta, it is equal to delta E. Okay, now this is delta E. Okay, now what do I have to do? Of course, we can substitute now. Okay, now Q1, Q2, this is what I have. Okay, let me just put them down so that we can use them. Okay, okay, now let's see here. Okay, so this is what we have. Okay, so let's see here. This is Q1, this is what? Q2, right? Okay, so we will substitute now. Okay, so of course, as you are aware, the nu is equal to what? 2. We have, okay, okay. So that is going to be now, okay, I will substitute, right? Okay, that is RT nu F, okay. I don't have to do that. So 8.314, okay, 29815 Kelvin, okay, nu is equal to 2, 96485 coulomb per mole. Then Q1, of course, this is now Q1, okay, so I will have this here, okay, so that is a Q1, you can see that, okay, I will put it here, okay, and I have what? Q2, which is this, okay. Okay, fine, okay, so that is what we are going to now look at. Okay, what will happen? Of course, you could see that I can cancel what? This here, all this here will be cancelled. The, of course, standard concentration will also cancel. As a result, this here goes what? It will go up, and this goes what? Down, right? Okay, so that this means now your delta E, okay, your delta E, okay, is going to be, okay, so this is our delta E now. So what will happen? Of course, you could see that this will cancel, right? Okay, and this will cancel. Okay, 5. We will be left with 15 and 5. Yeah, 15 and 5. So that should be here. Okay, we have what? 15 squared and 5 squared. Okay, this is what we are going to be left with. 15 squared and 5 squared. Okay, when we cancel. Okay, so are you okay? Okay. Yes. So 15 on the top, yes. 15 squared and 5 squared. Okay. So this is your equation. Of course, you have to calculate. Okay. The answer, if you calculate, the answer is going to be equal to 0.028, okay, 25 volt. Okay. This is 0.02825 volt. Okay. So this is it. Right? Okay, now this is the question 9. Okay, now we can look at other questions. Actually, there is a question immediately after that. I don't prefer to, in this seat here, 915, 916. I don't want to do that one now, okay, for a reason, let's do more so that we can practice more, and then we will be able to we'll look at that question, okay. So what is it we have? Let's say if we have this question, for example, okay, which is what? 917. What does it say 917? 917 says, write the cell reactions, okay, cell reactions, okay, so I want to write the cell reaction and electrode half reactions. Actually, I have to write the electrode half reactions before I can write the cell reaction. I cannot write the cell reaction before I write the two reduction half reactions. So take it as a rule, whenever you want to solve the reduction electrochemistry course questions, whenever you want to solve electrochemistry question, make it a rule, okay, that or a habit that you have to write the reduction half reactions, the two reduction half reactions. Okay, so now I'll just show you something, before I start here. Now you could see that 917, there are several parts. You could see here, this is 917, right? Okay, there are several parts, but I cannot solve all of these, right? Okay, and even some of these parts have relation with maybe some of the materials that I have not covered. So I am just picking the parts that I'm sure that I have covered the material. Okay, that's it. Okay, now what we need actually is solve and write the reduction half reactions and the cell reaction. What do we do? We will start by writing the reduction half reactions. Of course, right, okay, and left. Okay, so the right and the left. What do we have on the right? You could see on the right, okay, I have this here. This is on the right, okay? And on the left, I have this here on the left, okay? So this is the right and this is the left. Let me change this here. Okay, so what I have here, it is, okay, this is what I have. This is the left and right. Okay, so left and right. Okay, what do we have to do? We have to write the reduction half reactions. Okay, now you could see that here, okay, this is oxidation, right? Okay, the oxidation is supposed to be, I always follow that. your book is not always following it. يعني it's not always showing you the order in which the reduction half reaction is taking place or the reaction is taking place. I am always showing you, they are always, maybe I think the book sometimes they are, mostly they are writing reduction or giving the notation in terms of reduction on both sides. Okay, but sometimes they do it they do the opposite. Now, I usually do this here. I usually put the species in the cell notation in the order that the reaction is taking place. What does it mean? It means now this reaction, is it actually Cl2 converted to Cl minus? And this is Cl minus, right? Is it Cl2 converted to Cl minus? Actually, it is not. It is actually the opposite. So what I usually do in my cell notation, I write the opposite, but your book is not doing it. So here, actually, it is what? On the left here, we have what? We have Cl minus, Cl2 plus what? 2 electrons giving us what? 2 Cl minus, right? Okay, this is what is happening. And it is actually what? On the left, it is actually, your book is giving you that, telling you that Cl2 is converted to Cl minus, okay, which is reduction. Actually, because the book, as I said, they are always what? In the standard potential table, they only have reduction half reactions. But the actually, this is not what is happening. Actually, it is what? HCl to Cl minus. In real, what do you mean? I don't know. Cl2 plus 2 electrons, it is 2 Cl minus. Actually, what we have HCl, but what is there in this reduction half reaction? It is the Cl minus, okay, and Cl2. This is what we have. Okay, if you go and look at it, okay, you will see that it is, okay, Cl2, okay, sorry, this is going to be here, okay, this Cl2 plus, okay, this is what we have, right, okay, we don't have HCl there, okay, so what we, I'm writing Cl2 plus 2 electrons is giving me what? Is giving me 2 Cl minus. This is a reduction half reaction. In reality, it is not reduction. In reality, it is what? It is actually oxidation, right? Where the Cl minus is converted to what? Cl2. Fine. Okay. So now this is the left. But always make it a habit. Always start with the reduction. Always, because the right must be first. The right, we have to write the, because in our, when we want to calculate E cell, for example, later on, E cell standard, it is going to be equal to E right minus E left. Okay, and you have always to specify the right and the left, because if you make a mistake in specifying the right and the left, everything will be wrong, based on that. Anyway, so what do we have here? We have what? We want to the right. What is the right? Of course, I have again Br2, okay, which is, of course, this is now liquid, right? Okay, the Cl2 here, okay, it is what? Cl2 is what? It is a gas. This is what? Aqueous, right? Okay, now Br2 is liquid plus what? 2 electrons giving me what? 2 Br minus, okay, aqueous. Or again, it is what? This Br minus, where it is here, okay, and Cl minus is here, okay. Now, so Br2 is liquid. You can see that here, okay. Fine. Okay. So what we have is this. Okay. We are going now to. This is the. We need to get the overall reaction. What is the overall reaction? Overall is going to be. Overall reaction is going to be right minus left. Always right minus left. This is what I said, Once you have a mistake in specifying the left and the right, your overall reaction will be wrong. Your E cell standard will be wrong. Your quotient will be wrong. Your E cell will be wrong. Everything that you do based on that will be wrong, and the whole question will be wrong. Any analysis, any questions, okay, related to your answer will be also, whatever analysis you do based on your answer will also be wrong, because your answer is wrong. Anyway, what is the right and minus left overall reaction? What would it be? طبعا we have what, I don't want to repeat every time, but I'm not just doing it, just to make sure, this is what we have here, and this is what we have here, okay? and now we have also the other side here, okay, and it is right, okay, and fine, okay. So we have, of course, a negative sign here that is going to be right. This is what I have, minus here, okay, and this is okay, minus here. Okay, now this is of course our we subtracted, right? Okay, and we are trying to do the overall reaction. Our overall reaction will be, of course, without negative signs. I mean, we should not have negative signs between the terms. Okay, they should be all what? They should be all what? Positive, right? Okay, as a result, we know that what? You have to cancel now. The electrons will be cancelled. Okay, so that's why when we write reduction half reactions, we have to make sure that when we write reduction half reactions, we have to make sure that the electrons are cancelled. Okay, so they have to be the same in the on the right, on the left. Okay, what is it we have now? Of course, I will have to write the overall reaction. Er2 liquid, okay, plus 2Cl minus, okay, aqueous. It is giving you 2Br minus, okay, aqueous, okay, plus Cl2 gas. This is your overall reaction, okay? So this is the overall reaction, right? Okay. Now, the question is asking me to do what? To write the cell reaction and the cell reaction and the electrode and electrode half reactions, the reduction half reactions and the overall reaction. This is what we want to do. Okay, so as a result, we are done in this part here. Okay, but you are going later on, you are going to see that we have other questions, and these other questions are based on this here. What we have done now, we will have to use this to solve other questions. So this is what? One question, and then we are going to ask later on other questions. They will be using what we found now here. Okay, now let's see what is it we have. We have to write also for part E. So for part E, what is it? Part E. And part E is what? Is also a question where we want to, okay, where we, let's see here, is it this one here? Yes. Yes, this is the one. This part E. Okay, so let's try to solve part E. Okay, so what is it in part E? Again, we have here what? We have what? Left, right. Okay, now what is happening? Is it actually if Fe3 plus is converted to Fe2 plus? Left, of course, it is what? It is oxidation. This is what? Oxidation. Okay, and this is what? This is reduction. Okay, is it actually Fe3 plus converted to Fe2 plus? Is it? Okay, it is not. It is actually the opposite, right? Where it is oxidation, where Fe2 plus is converted to Fe3 plus, right? Okay, that is on the left. Now on the right, what is happening? On the right, it is actually Sn4 plus is converted to Sn2 plus, which is what? It is actually what? Reduction. So reduction here are, it will be what? Sn4 plus 2 electrons. Of course, again, it has to be aqueous here. It's giving me Sn, okay, 2 plus. Well, is it, let me just check, I'm doing the right thing here. Yeah, yes, yeah. Yes, I'm solving this part. Okay, this is aqueous. Fine. This is the left. Now, the right. The left is going to be what? The left is going to be Fe3 plus. Of course, you have one electron here. It is giving what? Fe2 plus. But this is actually oxidation. You could see that I have to multiply the equation by what? I have to multiply the equation by 2, right? Okay, because it is what? I have to have matching, okay, number of electrons. So there should be 2 here, 2 here, and 2 there. So that should be my equation for part E, okay, or the reaction half reactions for part E. Now, to find the overall reaction, it will be what? Right, okay, right minus left overall, okay, right minus left. Again, this is what we, I'm repeating again and again. That is what we have here, okay, and on the left, okay, so this is what we have. Okay, and we are now having this here. Okay, so let's see here. This is what I have now, and I will just put the signs, right? Okay, so they have to be, okay, sorry. Have to be, of course. Okay, so this is going to be here negative here, right here. So we have here, okay, I have this is minus, okay, and this is also minus, right? Okay, so this is my my reaction. Now my reaction, you could see that I will cancel what? The electrons here, they must cancel, right? Okay, and if I write the equation again, I will have Sn 4 plus aqueous on the left plus what? Plus 2 Fe2 plus aqueous, okay, it is giving us, okay, Sn 2 plus aqueous, okay, plus 2 Fe3 plus aqueous. So this is oxidation for the Fe2 plus to Fe3 plus, and it is a reduction for the Sn4 plus to Sn2 plus. Fine. So this is a question. Okay, now what is another question here? Okay, see the other question. Okay, what is it we have? What does it say? It says this is no, not this number. Okay, okay. So let's see here. Okay, I have to copy that question. Okay, so what is it? I have, we have done, this is C here, 918, okay, 918. So this 917, 918, right? Okay, so I'm right here. So this is what we want to do. Okay, it says now, write what? Write the Nernst equations for the cells in the preceding exercise. Preceding one is 917, right? Okay, so I have to write, so it means I will have to go and what? Put what, يعني, look at the parts of number 17, right? Okay, so the parts of number 17, they are these. These are the parts of number 17, right? Okay, these are the parts. Okay, it means, what does it mean now? Okay, يعني supposing I did not ask you the previous questions. Okay, supposing I did not ask the previous questions. Okay, I just came here and I said started. Okay, I will just okay. Okay, supposing I did not ask you these questions, okay, يعني the previous ones. I just said, now write the Nernst equation for these reactions. What is it you will do? Okay, and to write the Nernst equation, okay, you have to first write the equation, E cell, it is equal to E cell standard, okay, minus RT over nu F times ln Q. Okay, so you have to apply it for reaction, the reaction that we have to in reaction D and E. So, but supposing I did not ask you the previous questions, okay, I did not ask. So what is it you have to do? You will have to write the reduction half reaction, and right left, okay, and then you have to find what? Right minus what? Left, okay. Then you have to, so as to be able to write what? The quotient, right? Okay, so this is what you have to do, even if I did not ask the previous question. Okay, you have to do all that. Okay, so so I will go back and copy. Okay, so this is what we had previously, right? Okay, we had the, I will copy all this, okay, just to, okay, make sure that we have everything, okay, and we can, okay, release what we erase what we don't need. Okay, so that is part, I'm talking about what? Part D now, part D. Okay, part D. So what is it we have in part D? It says, write the Nernst equation. So as to write the Nernst equation, I will have, of course, to have the overall reaction. But in case I want to solve later on, يعني, I want to find what? I want to find the E cell, right? It means I have to find E cell standard, right? It means I will have to go to the table and read E right and E left. Okay, so make it always a practice. Whenever you go to the table to read a reduction half reaction, make it a habit that you also record the potential. You might need it later on. Okay, so you might, instead of going يعني, again and again to the table, Okay, so just go to the table, write the reduction half reaction, at the same time write the cell potential or the potential of the electrode. Maybe you will need it later on, who knows. يعني, anyway, so see, this is what we have. Okay, we need the reduction half reaction, which we have written previously. Okay, why? Because I will need to write the quotient. Okay, so the overall reaction. Now, the quotient is equal to what? The quotient will be equal to, okay, of course, I will have to write what? The activity of Cl2 gas. Okay, activity of Br minus aqueous, that is squared. Activity of Br2 liquid, okay, and activity of Cl minus aqueous, okay, squared. Now, I usually make it a habit so as not to forget. I write the what belongs to the same reduction half reaction up and down يعني. Okay, so it means I always try to maintain, okay, that, well, be organized يعني, just to us not to forget. See here, I am trying to say, but this is what this belongs to one reduction half reaction, and this belongs to the other reduction half reaction. Okay, so as to make sure that well, I have everything in, because actually many students make mistakes when writing quotients simply because the mistakes that I have seen previously, that many students actually will forget the powers, these powers, they will forget the powers. Okay, this is one. And sometimes they write them in the quotient, but they don't use them in calculation. And the very, very, very common mistake, I have seen it happening, like I would say, like more than 75% of students are doing it, and I don't know why. Up to this date, I don't know why. I don't know the reason why students are doing this mistake. This is len Q. So you have to put the Q and take the len of the Q. The thing is, at least 75% of students are only substituting for Q. They will just put Q here. And instead of calculating len Q, they put a Q and they do the calculation based on RT nu F times Q instead of len Q, which of course it ruins everything. Anyway, so what do we do? What do we have to do now here? This is the activities. Activity of Cl2, because it is a gas, is going to be equal to the partial pressure of Cl2 divided by the standard pressure, as you are aware, right? Okay. Activity of Br minus is going to be equal to concentration of Br minus divided by the standard concentration. Okay. Activity of Cl minus is going to be equal to the concentration of Cl minus divided by the standard concentration. Activity of Br2 liquid is going to be equal to 1. Okay, so as a result, I can go back to my quotient and cannot replace the activities, right? Okay, so I will go to the quotient and replace the activities. So I will say now, okay, this is going to be equal to what? This is going to be equal to the pressure of Cl2, okay, divided by the standard. This is going to be equal to what? The concentration of Br minus, okay? This is going to be equal to the concentration of what? Cl minus, okay, squared, and this is going to go away because it is equal to 1. This is our quotient, right? Okay, this is the quotient, right? Okay, and I'll be able, of course, okay, fine. Okay, so this is the quotient. So what do we do? Of course, we have to put our now nu is equal to what? Nu, according to this to the reduction half reaction that we have. Sorry, nu is equal to what? It is equal to the value of nu. It is equal to 2, right? Okay, so it means you go and put your Nernst equation and substitute here. You are not going to calculate. You just want to, okay, put the value of nu. So that should be here. Nu is equal to 2 here. Okay, you could see that it is 2. This is 2 from our reaction. And len Q, of course, okay, it's going to be equal to this. Right, okay. Okay, so this is regarding the reaction that you have in in part E, in part D. Okay, you have, of course, we have to repeat for part E, but we don't have time now to do it. Okay, so instead of starting and repeating again. We'll just do it next time. Okay? Thank you. Thank you. Thank you. Thank you all. Thank you, Arwa.